150 tons of gross weight is the threshold where standard transportation ends and the realm of heavy off-road giants begins. These specialized platforms are engineered to traverse shifting sand dunes and unstable desert terrain that would instantly immobilize conventional wheeled machinery. Why do these rolling fortresses require tires that exceed 2 meters in height? At first glance, the scale seems excessive, but in reality, the massive surface area of the rubber is the only physical factor preventing the vehicle from sinking into the fine, heated silt of the deep desert. Such machines operate in extreme temperature zones where the thermometer regularly surpasses 50 degrees Celsius, requiring cooling systems of industrial proportions. One can notice how the heavy-duty cooling fans draw in massive volumes of air to prevent engine seizure in the stagnant heat. These vehicles remain unknown to the general public, yet they perform critical logistics in the most inaccessible regions of the planet. They function as mobile bases for civilian scientific expeditions and provide the heavy lifting capacity required for the most demanding military supply chains. It gets more complex further on. The suspension systems on these units are designed with hydraulic stabilizers that compensate for the uneven shifting of sand under the load. 500 kilometers of uninhabited wasteland is a standard operational range for these mechanical systems. They transport essential cargo across remote territories where paved infrastructure is entirely non-existent. The equipment gradually navigates through extreme topographical obstacles that would destroy the drivetrain of any standard utility truck within minutes. It is visible how the reinforced axles distribute thousands of foot-pounds of torque to each individual wheel to maintain forward momentum. Everything only gets more complicated when considering the specialized variants designed for specific industrial and tactical roles. These trucks represent the absolute peak of off-road engineering, serving as the primary link in global supply chains that cross the world's harshest environments. This is not the limit of their capabilities, as the most massive units possess dimensions that redefine the standard understanding of automotive power. The largest of these desert titans operates on a scale that serves a singular, specialized purpose at the very top of the industrial hierarchy. The movement of these giants concludes the initial phase of desert logistics as they reach their destination. The technical journey into the world of ultra-heavy transportation continues through the analysis of each specific model. 8 wheels drive the vehicle forward across shifting sands where traditional transport fails. At first glance, the Tatra 815 8x8 might not seem that special, but for anyone who knows what it takes to cross a desert, this truck is a legend of engineering. Why did this specific platform become a global standard for endurance in hostile environments? The secret lies in a design originally engineered in the former Czechoslovakia for heavy military applications. This vehicle quickly proved to be one of the most reliable assets in the world, capable of conquering the planet's harshest deserts. It is visible how the massive 1,800 Newton-meters of torque allow the machine to climb steep dunes without losing momentum. The engine is a 19-liter V12 diesel power plant that produces between 360 and 400 horsepower. One can notice the steady vibrations of the block as it generates enough force to move the frame even when fully loaded with equipment. But this is just the beginning. Top speed reaches approximately 60 miles per hour. While it seems like a modest figure, this is more than enough for long-haul desert missions where stability is prioritized over velocity. The equipment gradually reveals its most significant technical advantage in the unique tubular backbone chassis and independent suspension on all 8 wheels. It looks outwardly simple to use a standard frame, but in reality, this specialized setup lets the truck maintain traction on highly uneven ground. This mechanical configuration is a game-changer when navigating loose sand and rocky terrain. The 8x8 all-wheel drive system works in tandem with a perfect weight distribution to ensure the vehicle remains stable in deep craters and areas with almost zero grip. Everything only gets more complicated when the terrain turns to jagged rock. A 10-speed manual gearbox equipped with a reducer gives the driver total control over the delivery of power. This is essential in remote areas with no roads or support, where a single mistake can lead to immobilization. Visually, the machine means business with a boxy front end and high ground clearance that allows it to pass over obstacles that would bottom out a standard truck. Wide off-road tires rotate ceaselessly, gripping the surface with a massive contact patch. It gets more complex further on as the vehicle moves from military to civilian service. In the field, the Tatra 815 has been utilized in scientific and military expeditions across the Sahara, the Gobi Desert, and even the arid regions of Mongolia. Civilian versions have been modified for geological exploration, often featuring livable modules attached to the rear bed. One can notice how these mobile units provide a self-sustained environment for researchers in total isolation. One notable expedition in the 1990s used a Tatra 815 to fully cross the Kalahari Desert. The truck completed the entire journey through extreme sand and heat with zero mechanical failures. It only looks obvious that a truck should survive such a trip, but in reality, the lack of support makes any breakdown a life-threatening event. If desert dominance was only about brute force, the Tatra proves that smart engineering and endurance are just as crucial. Transition to the next level of heavy machinery is inevitable. The process of exploring the limits of desert transport is only gaining momentum. The next truck takes raw power to a whole new level, designed to carry actual heavy loads across even more punishing landscapes. 700 horsepower and 3,100 Newton-meters of torque are the baseline performance metrics for a machine designed to survive the desert. The environment does not tolerate errors, as blistering heat and unstable sand dunes present constant physical challenges. But the Oshkosh M1070 Het was engineered specifically to master these conditions. Why must a logistics truck possess the power of a locomotive? One can notice how the 18-liter Caterpillar C18 engine occupies the space beneath the hood, providing the necessary force to move a 70-ton M1 Abrams tank through soft dunes and dry riverbeds. Without this immense torque, the heavy armored vehicle would simply sink into the shifting terrain, rendering the entire mission impossible. The process of desert transport is only gaining momentum. 8x8 is the drivetrain configuration that ensures the truck maintains traction across the most unpredictable surfaces. While hauling a full 70-ton load, the machine can reach speeds of 50 miles per hour, and when the trailer is empty, it pushes beyond 62 miles per hour. Heavy-duty leaf spring suspension systems work in tandem with the axles to provide stability on steep, sandy inclines. One can notice how the chassis remains level even as the wheels traverse deep ruts. The equipment gradually overcomes obstacles that would stop standard transport vehicles. A 7-speed automatic transmission is electronically controlled to manage the engine output. This allows the driver to maintain focus on the external environment rather than manual gear shifting during critical maneuvers. But this is just the beginning. It only looks obvious that such a vehicle is purely for combat, but in reality, civilian versions of the M1070 exist for specialized extreme missions. The truck features a raised cab, a reinforced frame, and an extended trailer platform, making it a logistics powerhouse regardless of the sector. It is visible how the massive frame absorbs the stress of the heavy load. In 2003, a specific unit supported the construction of a remote research station deep within the Sahara. It transported generators, water supplies, and shelter modules over 750 miles of unpaved desert, proving its utility outside of military operations. Its performance in the deserts of Saudi Arabia, Afghanistan, and the Sahel has solidified its reputation as the primary choice for moving massive loads where no roads exist. Everything only gets more complicated as the weight increases, yet the mechanics of the Oshkosh continue to function under the sun. The vehicle effectively bridges the gap between raw power and mechanical endurance in high-temperature zones. This concludes the overview of the heavy equipment transporter as it finishes its task in the sand. 445 horsepower pulses through the heavy steel frame of the Oshkosh M1070 8x8, a machine defined by its multi-role military heritage. Why does a logistics vehicle designed for the battlefield become a primary choice for civilian desert expeditions? At first glance, the sheer scale of the truck seems impractical for anything but war, but in reality, its ability to function as a mobile repair shop, a refueling station, or a heavy-duty hauler makes it a modular powerhouse in the sand. One can notice how the 12-liter Detroit diesel 8V92TA engine sits at the heart of the chassis. This V8 engine generates 1,700 Newton-meters of torque, providing the mechanical force necessary to push through shifting dunes. But this is just the beginning. The vehicle possesses a flat front, and a wide modular body that stands out against the horizon of the Sahara or the Sinai. It is visible how the reinforced independent suspension absorbs the impact of sharp inclines and dry riverbeds, while the 8x8 drivetrain maintains constant traction. Even when carrying 11 tons of payload, the truck maintains a steady pace of 62 miles per hour. The automatic transmission functions to decrease driver fatigue during missions that can span hundreds of miles of desolate terrain. Everything only gets more complicated as these military assets transition into the hands of global overlanders. Hardcore travelers have converted these rugged platforms into completely self-sufficient expedition rigs equipped with solar panels, high-capacity fuel tanks, and integrated living quarters. It does not end at this stage. These custom motorhomes have successfully crossed the Namib Desert and the Australian outback, proving their reliability as mobile bases that can operate in isolation for weeks. Major film productions also utilize the platform to transport heavy cinema equipment into remote, inaccessible desert locations where standard logistics would fail. The process of conversion highlights the fundamental toughness of the original design. 10-driven wheels are the defining characteristic of the next machine, pushing the limits of off-road engineering even further than the 8-wheel configuration. The transition to the next level of traction ensures that getting stuck becomes a physical impossibility. The heavy drivetrain continues to move forward across the sand without hesitation. 10 wheels are the defining characteristic of the Oshkosh M1074 palletized load system, a machine that redefines the limits of heavy-duty desert traction. Why would an engineering team move beyond the standard 8-wheel configuration? At first glance, the complexity of a 10x10 drive system seems excessive for standard transport. But in reality, this specific architecture is the only way to ensure full-time contact with the ground when hauling massive payloads across shifting dunes or jagged rock faces. The machine functions as a self-contained logistical hub designed for brute force and high adaptability. One can notice how the heart of this titan, a 15.2-liter Caterpillar C15 engine, generates 600 horsepower and over 2,500 Newton-meters of torque. The equipment gradually accelerates even when burdened with 20 tons of cargo, maintaining a consistent speed of 56 miles per hour across open, unforgiving terrain. This performance remains a rare feat for a vehicle of such immense dimensions and weight. The process is only gaining momentum as the truck approaches its destination. Central to its operational success is the Integrated Load Handling System, often referred to as the LHS. It is visible how the hydraulic arm maneuvers, allowing the truck to independently load and unload standard containers without the assistance of external cranes or support vehicles. For deep exploration missions where self-reliant logistics are a fundamental requirement, this specific capability fundamentally alters the operational landscape. The 10x10 drive system works in tandem with an adjustable hydro-pneumatic suspension that manages the vertical movement of each axle. This allows the M1074 to adapt to the terrain in real time, maintaining superior grip on soft sand, uneven slopes, or sharp, rocky trails. The suspension cylinders hiss with hydraulic pressure as they compensate for ground irregularities. But this is just the beginning of the vehicle's history. The Oshkosh M1074 has proven its durability during demanding Sahara crossings and humanitarian missions in the world's most remote and isolated regions. Scientists frequently utilize its stable platform for collecting field data in high-risk desert zones where mechanical failure is not an option. It does not end at this stage, as even the National Aeronautics and Space Administration utilized a modified version of this platform. NASA engineers deployed the truck for simulating lunar missions, testing its specific performance characteristics on unstable ground that mimics extraterrestrial environments. One can notice the slow, methodical movement of the tires as they churn through fine dust to validate survival strategies for other worlds. Everything only gets more complicated as the focus shifts toward a different kind of desert crossing. The next vehicle transitions from the rugged requirements of the battlefield into the specialized world of luxury exploration. This evolution replaces the utilitarian focus of the Oshkosh with a 5-star hotel on wheels, designed specifically for desert survival in a state of absolute comfort. The metal is ready for this transformation, moving from raw military power to sophisticated mobile architecture. 540 horsepower, that is the output generated by the 12.4-liter engine, residing beneath the heavy cabin of the Unicat November 95 hotel. Why would a vehicle require such immense power and 12.4 liters of displacement? At first glance, it seems like excessive force for a mobile dwelling, but in reality, this engine must propel a massive, fully equipped survival module across shifting desert sands and unstable mountain trails. A torque of 2,400 Newton meters ensures the wheels do not stall even when buried deep in soft earth. The chassis of the MAN TGS 8x8 serves as the structural foundation for this expedition machine. A 12-speed automated gearbox manages the power distribution with electronic precision, maintaining smooth performance under the stress of extreme heat. One can notice how the 8x8 all-wheel drive system engages, utilizing differential locks to maintain traction on surfaces where standard vehicles would immediately fail. It gets more complex further on. Integrated onboard systems allow for the active adjustment of tire pressure depending on the specific resistance of the terrain. This is a critical technical capability for traversing rocky riverbeds or scaling dunes that stretch for hundreds of miles. The equipment gradually adapts the footprint of the tires, preventing the truck from sinking into the loose substrate of the Sahara or the Gobi. But this is just the beginning. Inside the modular cabin, the engineering shifts from mechanical power to life support and total self-sufficiency. The interior contains a full kitchen, king-size beds, and a pressurized shower system that functions regardless of external conditions. Fresh water tanks are supplemented by a dedicated desalination unit, allowing for the replenishment of resources in environments where water is scarce. High-output solar panels mounted on the roof capture energy to power the air conditioning and internal electronics. The process is only gaining momentum. An auxiliary generator serves as a redundant power source, while satellite communication arrays maintain a link to the outside world from the most remote coordinates on the planet. Why do scientists and elite explorers choose such a complex platform for their journeys? The necessity for maximum autonomy drives the design of every component, from the auto-leveling stabilizers to the integrated workshop. One can notice how the hydraulic stabilizers deploy on uneven ground, creating a perfectly level floor for the living module even on steep slopes. Therefore, the vehicle becomes a self-contained survival base capable of supporting a group for several weeks without external assistance. The camera glides along the exterior, revealing armored windows and a reinforced boxy silhouette that resembles a specialized tactical vehicle. At the rear, auxiliary fuel tanks and massive spare tires are mounted to a heavy-duty rack system. One specific unit successfully traversed the distance from Egypt to Morocco, covering over 2,500 miles of unforgiving terrain. Everything only gets more complicated. During that expedition, the crew relied entirely on the onboard systems for food, water, and shelter, stopping only when the diesel tanks required replenishment. The brand caters to wealthy adventurers and documentarians who require a machine that can withstand the most extreme environments on Earth. It looks like a creation from a science fiction narrative, yet every bolt and hydraulic line is engineered for the physical realities of off-road survival. The weight of the vehicle is distributed across 4 heavy-duty axles, ensuring stability during high-speed desert crossings. Metal panels protect the sensitive undercarriage components from impact with boulders and debris. The equipment operates ceaselessly, maintaining the climate inside the cabin while the exterior temperature exceeds 50 degrees Celsius. From here, the narrative moves toward machines of even greater scale and complexity. 1,500 liters of fuel can be stored in the auxiliary tanks to extend the operational range between stations. The transformation of a standard truck chassis into a global expedition platform is now complete. The vehicle stands ready to enter the most isolated regions of the globe where no infrastructure exists. This concludes the overview of the 8x8 Survival Titan. 808 horsepower is not the only metric of power, but it is where the mechanical soul of this machine begins. Why was such a massive platform engineered to traverse the most unforgiving landscapes on the planet? At first glance, the sheer scale of the vehicle seems excessive for standard transport, but in reality, the environment it inhabits demands nothing less than absolute technical dominance. The MAN HX-81 was developed in Germany specifically as a heavy military platform to carry the impossible across terrains where the Earth shows no mercy to standard machinery. One can notice the steady vibration of the chassis as the 20-liter MAN D2868 V8 engine cycles through its firing order. This massive power plant generates 730 horsepower and more than 3,000 Newton-meters of torque. Such raw strength is not merely for speed, but for the endurance required during long hauls involving over 130 tons of cargo. The process is only gaining momentum as the vehicle enters zones where temperatures exceed 120 degrees Fahrenheit. To manage this heat, the 12-speed automatic transmission operates under constant electronic management to ensure peak performance even when traction is nearly non-existent. The camera glides along the undercarriage to reveal the 8x8 drivetrain, which works in unison with a sophisticated hydro-pneumatic suspension system. This setup allows the driver to manipulate the tire pressure control, adapting the contact patch to match varying desert surfaces with an extra high ground clearance. It is visible how the vehicle rolls over dry valleys, loose dunes, and jagged gravel roads with the same stability found on paved highways. The design remains rooted in pure functionality, featuring a rugged front end and a modular rear platform designed to carry tanks, containers, or specialized scientific equipment. It only looks obvious that such a machine belongs in a theater of war, but in reality, its utility extends to geological and archaeological sectors. During one specific German archaeological expedition in Libya, this truck transported excavation gear over 500 miles of roadless terrain without any external support. Despite a massive empty weight exceeding 66,000 pounds, the platform remains shockingly stable. This is the direct result of decades of engineering focused on conquering the extreme. Everything only gets more complicated when the mission shifts from raw utility to high-end exploration. While this truck relies on brute force to succeed, the next phase of desert travel involves balancing that power with specialized luxury. The transition to the next level of machinery represents a tailor-made approach for elite expeditions. From here, the focus shifts toward a high-end machine designed for the most exclusive environments. 8 wheels and 540 horsepower define the mechanical presence of the Action Mobile Desert Challenger. Why would an expedition vehicle require such immense power and a 12.4-liter engine? Crossing the Sahara Desert usually demands sacrifice and discomfort, but this machine functions like a luxury yacht on wheels. By utilizing a MAN 8x8 chassis, the Austrian manufacturer creates one of the largest and most sophisticated off-road platforms in existence today. It can reach speeds exceeding 68 miles per hour while maintaining total stability on unpredictable terrain. One can notice how the adjustable air suspension absorbs the impact of jagged rocks and heat-cracked soil. 8x8 traction combined with differential locks ensures that the vehicle never loses momentum in deep dunes. An automated transmission manages the 2,500 Newton-meters of torque with surgical precision. It only looks obvious that such a heavy machine would sink into soft sand, but in reality, an integrated tire pressure system allows the operator to adjust the contact patch of the tires on the move. The camera glides along the massive exterior, where solar panels are mounted to provide constant energy. Everything only gets more complicated within the interior living quarters. 5 distinct systems provide the autonomy required to live off-grid for up to 3 weeks at a time. The interior contains a gourmet kitchen, a king-size bed, and a full bathroom with a water purification system. Satellite internet and a built-in workshop transform the living space into a mobile command center capable of operating in the most remote Middle Eastern regions or the Atacama Desert. The equipment gradually filters water and manages power loads without any external infrastructure. It seems simple to call this a luxury vehicle, but its history proves its technical utility. Professional BBC film crews have utilized the Desert Challenger to support operations in locations where no buildings or roads exist. While the scale of the truck suggests it is reserved for the ultra-wealthy, many overland enthusiasts have adopted this extreme lifestyle for months on end. They navigate vast open plains with the same comfort found in a high-end suite. The process is only gaining momentum as more explorers seek to combine rugged durability with high-tech amenities. The Desert Challenger confirms that the most extreme environments on Earth can be navigated with serious style. From here, the narrative shifts away from luxury toward a machine built for raw survival. 8 wheels and an all-wheel drive system. This is the physical foundation of the Unicat A1. an undisputed icon among military and expeditionary vehicles. Why did a truck developed in West Germany during the 1970s achieve such a legendary status? While its silhouette is recognizable globally, its reputation was forged over decades of service through one specific quality: extreme reliability. This is particularly evident in desert environments where mechanical failure often leads to permanent abandonment. One 12-liter V8 diesel engine provides the primary motive force for this machine. It generates 360 horsepower and approximately 1,700 Newton-meters of torque. At first glance, these specifications might appear modest when compared to modern heavy-duty trucks. However, the true value of this vehicle lies in its mechanical simplicity and bulletproof engineering. The process of moving across shifting landscapes is handled by an 8-speed manual transmission equipped with low-range gears. One can notice how the 8x8 traction system engages through manual locking differentials to prevent wheel spin in soft dunes or quicksand. This allows the truck to maintain momentum on unstable terrain where other vehicles would lose traction and sink. It does not end at this stage. A long-travel coil spring suspension system works ceaselessly to absorb the impact of rocky trails. The equipment gradually articulates over obstacles, keeping the oversized tires in constant contact with the ground. Its tall and robust cab sits high above the axles, providing a clear field of vision for navigating through sandstorms. The modular body design allows for various configurations, from military cargo beds to specialized habitation modules. Everything only gets more complicated when these vehicles are pushed to their limits in competitive environments. Modified units have successfully crossed the Gobi Desert and participated in the Africa Eco Race. During one civilian expedition stretching from Morocco to Chad, the truck covered over 1,500 miles of extreme heat and rocky paths. One can notice that the entire journey was completed without a single major mechanical failure occurring. The machine was not engineered to impress with data on a technical sheet, but rather to endure the most hostile conditions on Earth. It is visible how the heavy-duty chassis remains rigid under the stress of extreme off-road maneuvers. But this is just the beginning. The next vehicle in the sequence is not merely a rare find, but a massive machine specifically engineered for desert dominance. It features an aesthetic reminiscent of a science fiction film while maintaining extreme functional capabilities. Transition to the next level. 600 horsepower is the output generated by the massive 19-liter Cummins power plant hidden beneath the reinforced hood of this machine. Why would an American brand synonymous with polished chrome and smooth asphalt venture into the production of such a specialized titan? Most people associate the nameplate with highway transport, but in the 1980s, the company engineered a radical departure from its traditional lineup to conquer the most unforgiving terrain on the planet. The Kenworth 963 exists as a desert-exclusive heavy-duty monster. It was built specifically for extreme transport contracts in the Middle East, with a primary focus on the grueling demands of Saudi Arabia. One can notice how the design differs from any other model in the fleet, featuring a forward-set cab and air intakes mounted high to avoid the thickest layers of ground-level sand. It gets more complex further on. It seems simple to just build a larger truck, but in reality, the cooling system had to be completely reimagined to function in temperatures exceeding 130 degrees Fahrenheit. The 6x6 drivetrain and 18-speed manual gearbox work in tandem with reinforced axles to deliver over 2,500 Newton-meters of torque. Special filtration systems were integrated to prevent fine desert dust from choking the internal combustion process. The process is only gaining momentum. 50 tons is the minimum trailer weight this machine was expected to haul through deep, shifting dunes. It primarily served oil field operations and remote logistics, moving colossal drilling equipment through regions where roads do not exist. In these sectors, there is no support and absolutely no margin for failure. Some units demonstrated extreme endurance by running non-stop for more than 15 days under the intense radiation of the desert sun. It is visible how the heavy-duty chassis maintains its structural integrity despite the constant torsion from uneven sand. Today, only a few original 963 units remain in existence, making them highly sought after by specialized restorers. When a preserved example appears at a truck expo, it functions as a rolling relic from a different era of engineering. But this is not the limit. The top position is held by a vehicle so massive it required a custom-built runway just to exit the factory gates. This final Titan represents the absolute pinnacle of desert transport history. 16 feet of height and 16 feet of width. These are the proportions of a machine so immense that a specialized road had to be constructed just to facilitate its departure from the assembly plant. Why would such a massive vehicle be necessary in an era of standard logistics? At first glance, the desert seems like an impossible barrier for traditional heavy machinery, but the Berliet T100 was engineered specifically to solve the problem of transporting heavy oil equipment across the shifting sands of the Sahara. The process of moving this French colossus across the dunes only gets more complex as the terrain shifts. Designed in the late 1950s, the vehicle reaches a total length of nearly 50 feet. This mechanical giant functions as a mobile platform for missions that would defeat any other transport system. One can notice how the chassis maintains its position even on uneven surfaces. 600 horsepower is generated by the Cummins FIF 12 diesel engine that serves as the heart of the T100. This power plant produces more than 2,800 Newton-meters of torque, allowing the truck to maintain momentum regardless of the incline. The 6x6 drivetrain distributes this force across all axles simultaneously. The equipment gradually moves over dunes as if they were simple speed bumps because of the nearly 6-foot-tall tires. These specialized wheels were developed specifically for soft sand to prevent the 100-ton machine from sinking. It is visible how the tires deform slightly to increase the contact patch with the ground. Everything only gets more complicated when the terrain requires precise gear selection. 8 speeds are available through the manual transmission, which utilizes a dual reduction system to ensure brute torque is available at any point in the rotation range. Because crossing the Sahara requires total autonomy, the fuel tank was designed to hold 370 gallons of diesel. This allows the truck to operate for extended periods deep in the Algerian oil fields without support. But this is just the beginning of its mechanical capabilities. Despite the massive scale of the frame, the vehicle remains surprisingly stable due to a low center of gravity. Only 4 of these units were ever constructed, and they were tasked with hauling entire drilling towers and small bulldozers into the most remote desert regions. The camera glides along the massive steel beams that form the bed of the surviving unit, now preserved in the Berliet Museum in France. Human engineering reached a peak with this design, transforming it into a symbol of conquest over the impossible. The trucks do not merely carry cargo. They represent the ability to navigate routes that do not appear on any map. Heat and sand do not hinder the progress of the drivetrain as it continues pushing forward. Transition to the next level of durability is achieved through the use of heavy-gauge materials that withstand the punishing environment. The material and the machine are proof that extreme environments can be explored when the technology matches the scale of the challenge. Every mission carried out by the T100 further established its status as a myth of industrial history. From here, the legacy of the largest off-road truck ever built remains a testament to specialized engineering. The journey of the Colossus concludes as a permanent part of the history of desert exploration.